What? Like Tom is just okay?
No, Maru, he's a pretty awesome teacher.
No, yeah, he's
He's a pretty awesome teacher, and indubitably. All right, so looks like we're at the top of the hour. So I will go ahead and start us off. Welcome everybody to this semester's first Offensive Security Club. I appreciate you all being here and tuning in. If you haven't already, go ahead and fill out attendance. We have that attendance.offsec.club. Just go ahead and take some time to fill it out. It's just like 2 questions, like, hey, what day is it? You hear, or your email or whatever. And yeah, those numbers kind of give us good ground on statistics to report to other bodies that request them. Also, throughout this presentation and any discussions that arise, questions.offsec.club will be hosting questions, or you can drop them in the Discord as well. I'll check both over here on my laptop. If you have a question, I'll be checking it kind of off and on, so pardon me if I don't answer it right away as soon as it's sent. But yeah, you can send those at any time. All right, hot news, hot news, hot news. Thank you, Skylar, for finding this out. John Strands of Black Hills InfoSec is offering all his InfoSec training courses, pay what you can, including free. They are scheduled courses, so you'll have to check the training schedule listed down here in the link. And these slides are again available at slides.offsec.club. February 2 through 5th, they have that class. Da da da. It's a calendar. I'm not gonna show you how to read a calendar. You got it. Bread of the week, bear of birth, and you can read all the rest of that. I'm not going to read that out because some people don't like bread, and you know what? That's okay. Try Hack Me startups. We are starting up Try Hack Me King of the Hill competitions again. Those are going to be Friday at 6 p.m. to 7 p.m. Central Time. I'll usually try to post those links 2 hours beforehand at moshpit.offsec.club just to make sure that, well, I mean, I guess that's the only part where Try Hack Me actually doesn't let me create them any earlier than that. I wish I could schedule them easier, but 2 hours beforehand is when I'll post them. They'll be live here in the Discord. Anybody can join, regardless of skill level. It is kind of like a collaborative format where all the competitors, I do ask that you stream your screens or narrate us kind of what your process is, what you're going through, what you're doing. And that'll be live on the Discord. I won't record those just because they're kind of like impromptu, informal, out of the club type thing. When you sign up for it on tryhackme.com, just make sure you set your experience level to high or advanced, whatever, even if you consider yourself not, just so you can get into the competition page. Otherwise, it won't let you. We do have prizes if we do get enough participation. So, hope to see you there. All right, talking about injects. Injects in general. Oh, yeah, O365. I didn't know how to number courses, so just be random numbers. Look forward to that. The vocabulary, I don't really have a stickler knack in me for vocab for these types of topics, but organizing them was kind of a nice way to introduce lots of different things in a variety of fields or domains of security. So an inject is to introduce something into an unintended manner. And injects are normally caused by no sanitation or poor sanitation, um, throughout whatever system. And that can mess up a lot of things. Command execution can be caused, information disclosure can be caused, COVID can spread, authentication bypasses can happen. So, yeah. Talking about command injection, you may have done this in software security a little bit with some examples. I think they start you off with maybe some PHP command injection or something like that. I'm not really sure anymore, depending on the class. Normally, you'll see this in type of backend scripts and whatnot. It does vary because web-facing applications can have potential for command injection, and maybe listening server processes can have potential for command injection. These all vary in different methods. You'll see that we kind of split into 2 different methods. Some will be the OS command injections, where the operating system is actually running those because you called a command to the operating system and wanted to inject that. And other times it will be because the language itself is processing your input in its own programming language. So we'll see a couple of code examples of that. Here's some scripts I've written. This is the first one we start out with. This is kind of an operating system command injection. It's just a listening server. This is kind of an example from Black Hat Python book. just a TCP server. What it does is it listens on all addresses here on your local system on port 1336, and whenever you make a connection to it, it's going to say, I can make temp files. Go ahead and give me a file name to write. I'll write it. Don't worry. Well, what it does here is it creates a subprocess. It executes a system command with your user input directly formatted into here. This is a Python 3 kind of formatting method that Bailey Belsario showed me. Shout out to him. But it's the same if you were to concatenate it directly or use a different formatting method. It's kind of the same unless you try to sanitize or escape that input. As attackers, we can exploit this usually by knowing the operating system and knowing kind of the source code format for here. We can say, oh, hey, I can throw a semicolon right in here and then have a command shoot off. And actually, let me show an example of that right now. So we'll say concat os. So we're started the server, listening on there, netcat, localhost 1336 is what I have it on, and it's like, hey, I can make temp files. So I'm like, test, right? And it created a temp, and because of my garbage coding, it didn't output the right thing. But let me ls/temp. Oh, we've got test here. Oh, well, that's cool. That's great and all. That's the intended use of the application, or so we hope. So let's go ahead and make another file, and let's mess with it a little bit. Oh, well, that's a little bit interesting. And part of our response is actually in this little appended reply. But we can see that in the directory that this script was launched, we have these things in here. We can do it again and, do basic stuff, and we see that the username is Brawler. Oh, okay, cool. So that's basically the OS is handling that command injection, and it's processing that directly to the OS. It's not evaluating it in Python or anything, which is a little different from my next example here. We have a similarly dangerous type of script. It's a same TCP server, it's just running on a different port. If you want to go ahead and run these both at the same time, that's cool, whatever. But here you can see my request is being received, stored, and then we're using an eval function. Now, eval is a pretty dangerous function to use in general. In software security, you may learn or have learned that eval, or that you shouldn't use eval or system commands to do things. You should stick to what is needed and nothing less, nothing more, something like that. We can see here that it's evaluating this request, and then it's sending it back. So let's go ahead and take a look at that example. Exploitation on this one is a little bit different. You'll just have to focus on what language you are working with on the back end. Control-Shift-T. Let's see. Netcat 17001 337. And it says, I can do math. Give me some easy math statements. This does way better math than I do. Oh, cool, it can add numbers. Well, in a way, that's kind of an issue, because looking at the source code, right, we can see the evaluation of that request. There's no sanitation of that input. There's no specific function that we're saying to do math. We're saying evaluate this. Evaluate runs Python code. It has the capability of running Python code. You can import whatever libraries you need that are native to the system already, and you can pop a reverse shell. There, I think, was one Hack the Box box. I think it was something to do with GitHub, but basically they had an eval statement, and you would send a request to it, and then part of that request would be handled by eval, and you could actually get a reverse shell by Googling a one-liner. So you can go up here and you can Google eval one-liner reverse shell, and you can probably find a few things. I'm not going to kind of go into exploiting that, just because the command injection is already present and there's no sanitation that we have to bypass, so it's not really cool. Anyway, it's still cool. It's just not as cool to like bypass sanitation and stuff like that. Another example, Damn Vulnerable Web App. You all may have heard of that. If not, highly recommend it. It's an awesome learning tool. It is a bit dated, I will say, but I mean, I still read hacking books from the 90s, so whatever, right? the concepts are there. Here we have kind of a garbage solution that has been implemented. It's a in-house substitution, kind of a block list for certain characters. And you don't want to do this because people can subvert these with time and effort. I'd rather suggest that you use some type of framework to sanitize the user input or something like that. But here we can see it's just being directly appended after it's substituted and whatnot. You can bypass this by, well, if we see here, there's a pipe and then a space, turns into nothing. So you can actually bypass this by putting a 1 in the command field, and then a pipe, and then just instantly putting your command cat whatever XYZ. Here's some more examples, references, labs. There's the Try Hack Me command injection room. Highly recommend that. OWASP command injection. That kind of shows us that command injection is not just in web applications. It can be in some type of weird service you found or something like that. They have a couple examples of C code in there that handles that. If any of you participated in the Byte Club that went on, I think last year, that CTF, there were some examples of command injection in some of those services. I found that pretty useful, and it was just awesome CTFs overall. There's all the version changes and everything in there, so if you want to look at revision 1 and start from there, there's some pretty simple examples you might find with source code analysis. Here is a finding that I did some vulnerability research on. Basically, it's we found authenticated remote code execution in an LG TV running WebOS. Golodox Galino, I don't know how to pronounce that, whatever. Basically, it was pulling log files from a URL, and the file was requested via parameters. So that's how we got it to execute our commands. We actually just appended a semicolon to that file name, and after that we could have a command, and it executed as root, which was cool. Granted, it was inside of a BusyBox shell, but that's another story. Pretty cool research. Just goes to show that command injection vulnerabilities, I mean, they're still an issue, even if you think they're dated. Talking about SQL injection, I'm not really going to run you through what SQL is in general. Hopefully you've heard of the term or something, but in short, it's a query language. It talks to a database where you can pull data from that database, and it's the language you use to pull data from that database. It's one of the languages you can use. For SQL injection, we'll see that responses for this can be what I like to categorize as in-band, out-of-band, or inferred. And band really refers to the channel of communication. If you hack a target, how can there be a sequel if there isn't a first one? Thank you for the question. Prequels. Prequels, a good example. But going back to bands, bands are if you interface with an application and you have SQL injection on an app and it spits out output, that's a single band of communication. That's not anything you have to go out of the way to enact or retrieve data from. In band is going to be you put in data, you get out data. Same interface. There's no trivial script or cron job in the background that's shooting the results off somewhere. Out of band is a bit more obscure. You might have a system that emails you the results of a query or resets a certain password or does something that you can't really tell from that same band of communication what the results are. Inferred is more leaning towards blind, yes, no questions type of injections, and we'll get to more specific examples of what that means in a second. But yeah, those are 3 categories that most people have categorized them in. I took upon those categories and I was like, yeah, this is a good way to categorize stuff. SQL injection kind of goes back to unsafe concatenation, handling of user input in general. There's different syntaxes for different SQL languages. So like there's Oracle language, there's Microsoft SQL, MS SQL is what you may have seen that acronym as. There's MySQL, that's what Damn Vulnerable Web App runs. And there's a whole bunch of other ones that I can't think off from the top of my head, but you get it. It's a language, databases. We're going to be discussing time-based versus error-based, maybe some data structure implementation into our fuzzing, some syntax dependencies, and just examples and different tools for testing and automating. So we're talking about in-band SQL injection. On this left-hand corner, what I have is just the source code from Damn Vulnerable Web App SQL injection, not the blind one, just the regular SQL injection where you can get results in. We see here that there is some unsafe substitution / concatenation that's being put into.
Hello?
Mic turned off.
Angel, we can't hear you.
Baby, come back.
Mayday,
What are you
mayday!
doing? Hello?
Try turning the stream off and on again, maybe?
I think my audio just cut out there for a second. Gotcha.
Oh, okay. Yep, you're back.
Yeah, okay, cool. I just saw the question pop up. Sorry about that. Okay, let's see. Can you guys still hear me?
Yeah.
Yes.
Cool, awesome. All right, sorry about that. I'll just go back. Query, cool, whatever. Here's what the query looks like in the back end. We have select first name, last name, which are columns from users, which is our table, users, where the user ID is equivalent to, and this is where our variable substitution comes in. And that's just a PHP specific thing on the back end, right? And this equivalently, I don't know if that's a word, I'm making it one, translates to selecting a bunch of stuff if we want everything in the database. Because what we can do is we can say where user ID is 1 or where 1 is equal to 1. And 1 is always equal to 1, right? You may have used that in a while loop or something just for prototyping or whatnot. Or actual code. I've done that before. As we can see here on the left side, I've done a SQL injection and it's in band. And I've just gotten all the results from this table that we're querying, but it only gives me these two columns that we queried. Well, now how do we get other data from the table? Because there might be more columns, there might be other things in the database entirely that we need to get. So we'll talk about those things here in a second. This is just kind of a easy, like, hey, if you don't know what SQL injection is, here it is. Yeah, and that's something if you haven't learned in software security already, you'll hit in software security as well. Talking about out-of-band approaches, the injection is still present, and your response is just derived from another channel. So if you've ever tried to pop a shell on something, or maybe not even pop a shell, but try command execution on something, you may inject a command to ping back to your machine or something of that nature and watch Wireshark for that traffic, just because the command may not give you the exact response out, but you think it's still present. Well, either way, it's not really inferred. In terms of the data returned, we don't have to ask questions about it. There's some transfer of data back through a different channel. That's kind of a typo right there, no transfer of data back. And here's a little article on AccuMonitor's new out-of-band blind SQLI type of detection, and they go into detail on what it does to try to detect that in an automated fashion, which would be pretty cool if you were trying to build your own fuzzer. So just making sure mic's still good. Cool, it looks like my audio is still fine. And here are some more references to it. We got the Portswigger Web Security Labs blind SQL injection with out-of-band interaction, and data exfiltration. This is a white paper using DNS requests, abusing SQLI. I actually think they were working with an Oracle database, so there was a cool function in that Oracle database that allowed them to do that a lot easier than other languages. Talking about inferred injections, your injection is still present. Your response is just derived by a series of questions or tests, or there's not really a response back from the application with all that data. So for instance, if I were to inject into an application like the Invulnerable Web App, in fact, let me just switch over to that now. If I were to go to the Invulnerable Web App, renew my session really quick. Okay, we have blind. So normal queries, normal usage of this. I hit 1. Oh, user ID exists in the database. Notice how we're not getting back the actual data of that user ID, unlike the other one, where I can do user ID is 1, and it gives me some information. If the user ID is not in the database, then we get missing. Oh, okay, cool. Well, that's kind of the series of yes or no questions that I was talking about, because we can kind of play this game of go fish with the interface in the back end. So for instance, if I say, hey, you got any A's? Just an example, go fish. Okay, got any B's? And the app is silent or waits or does something, then, oh, there's a difference in response. You know, we can try to exfiltrate the data out of there using various cheeky methods. I will say, taking Tom's data structure class, don't let him know this, but I actually retained a good amount of information about binary search trees, because efficient fuzzing of these types of interfaces uses some type of binary search tree. If you were to try to guess every character in the password section in a database, right, or password column in a database, it would take a long time because you'd have to check every character, right? Well, we can actually, on certain languages, we can ask, is this character less than a certain ASCII value, or is this more than another ASCII value? And from there we can cut our time down to whatever O of n efficiency. I don't know all that language, but you get the gist. So basically we're asking questions. Now, how do we get some type of response maybe if we don't have anything that says oh yeah, that's valid, or no, that's valid, or not valid? Well, one method we can use is time-based SQL injection. We can ask the application to hash something for us. Hashing, if you get up there in terms of computing a hash over and over and over again, takes up compute cycles, it takes up time. Some languages may even offer their own wait or sleep options. In Microsoft SQL, we can actually perform a query where we say, if the length of this user, or the SQL user, is 1, wait for a delay 10. Otherwise, we're going to instantly respond or something like that. And you'll have to fine tune that to whatever your network connection is, in my experience. You don't want to just have it at 1 second, because then you misinterpret values and whatnot. You could really just confuse yourself. So going into it a bit more, here's an ASCII table reference. Binary search tree definitely comes into play. We can say, if the substring that's lowercase is greater than the ASCII value of 97, wait for this delay. And at that point, let me go ahead and open up the link here. At that point, if the value is greater than 97, oh, we know it's one of these lowercase letters, which is kind of redundant. You'll have to pardon my example because we converted it to lowercase letters before we got the ASCII value. But from here, you could say, is it greater than 110? Boom, and now the half of the alphabet is knocked out if it's not. So that's just something to kind of take in. I have read some white papers. I couldn't find an example that's kind of up to date where you can play with certain comparisons, and there are different types of operators that can bypass web application firewalls if they're just using some garbage regex or something like that to match what your input is doing. So here's kind of the blind injection, just the source code for it. If we get feedback, user ID exists, otherwise user ID is missing. Okay, well, at least we have yes or no questions to ask. So on here, we basically have this same query that I did in the first one, and like I showed you all earlier, it looks like we have nothing back besides user ID exists. Okay, well, that kind of sucks, but we know it's valid. Well, now we have to enumerate certain things out of the database. Order by is a certain clause, I guess is the term for it. It might not be clause. Basically, this gets the number of columns being returned by the query. In this case, we can look at our query and we know the backend query, what it is. You might not always on black box tests, but we see that first name and last name are being selected. Those columns are being selected from this database, from this table in the database. So we'll order by 2, and that means, hey, it's 2 columns, right? And it's like, yeah, sure, there's 2 columns. Okay, cool. We'll say 1, and it's like, hey, there's not 3 columns in this database. If you're curious about the syntax here, I did 1 just because it is a valid thing, and I want it to return a valid query, and then order by to find out the number of columns. The dashes and space at the end are just commenting out the rest of the query. And then we can even combine logical statements. So if you've ever done programming languages where you have if condition is met and condition B is met, then do this. Well, we can do the same thing in here. We can say if the user ID 1 exists and 1 is equivalent to 1 exists. Cool, it works. This one does have a typo. I was missing a single quote in there that actually turns it into an injection. For some reason it actually worked though. I guess it's just a one-time fluke, but you would of course put your single quote right here and have the comment go out. So now, comparing these logical operators, I say 1 is the user ID and 1 is equal to 2, right? And now it's like, hey, that's wrong. Like you suck, you're dumb. And at that point, we know we can combine operators together, or combine certain statements together to get results. So how do we go about doing this? Well, in MySQL, it's going to vary language to language. You'll have to do research on what works. My recommendation is for you is if you're going up against a certain database, what I would do is I would go into your backend. So here I have Damn Vulnerable Web App running as Docker container, Docker exec. You don't have to know this exactly. It's just, just kind of wherever you're running this. If you're running it as its own entire VM, that's totally fine too. Okay, so here I'm in a shell inside my Damn Vulnerable Web App. I'm just going to type MySQL, use, let's actually show databases if you're not familiar with syntax. Okay, cool. Let's use Damn Vulnerable Web App. Cool. And then let's say show tables. So what I suggest you do is, working with the backend you want, come in here and formulate your queries as if they were fully valid queries. So do the whole like select first name, last name from users where user ID equals 1. Oh, typo. Oh no! Whatever, you get it. Boop. Damn Vulnerable Web App. Come back into here. Oh, okay, cool. We return admin and admin as those two columns because we requested those. And if you want to pull everything from there and have a quick and dirty way of seeing what's in those, what columns there are available, select everything. It might be a little messy, but yeah, that's just a kind of what I would do to familiarize yourself with there. That way you have those errors to go off of. Here's an example of extracting that data. Basically, I have 1 and ASCII. What's the ASCII value? Is the ASCII value of lowercase substring selecting from this query, which is select user from users where user ID is equal to 1. Is that greater than 110? This is just basically to get the username from the users table. So you might want to be after the password or email or flag whatever. Or if you're actually working on a pen test, you may want to just try to enumerate whatever you can and just kind of show shock value of one user example. And to change this substring of which letter we select, we just increment this value right here. Go along there. And this is language dependent, so it's not like this is how it is and this is the only way it's happening. Let's see, let me check questions real quick. Okay, cool. One of my suggestions and recommendations is to try writing your own fuzzer. Basic apps like Damn Vulnerable Web App, you can just go off of these queries here. So if you'll notice here in the parameters and the get request here, we can actually just have our query run from this. So you could make a bash script that fuzzes it and checks if these strings are greater than 1 or greater than 2. Mess with the ASCII values and enumerate it that way. So yeah, let me go ahead. Talking about union-based, some of you have worked with union. Union is a method to connect queries together. Funny little gotcha about unions in SQL in general is that if you have a query, and like our query in Damn Vulnerable Web App is pulling 2 fields or 2 columns, our union has to also pull 2 columns. So we run into this kind of problem where we may not be able to extract all the data we want at the same time or from the same request. What you can do is, if you don't know any of the other columns, you can go ahead and put null here. So for instance, after my injection, I do union select table name null from information schema tables, and this just returns me a list of the tables that are in the database, and that's just MySQL specific. Could be different on your backend. Union select column name, checking out the column names that are possible, and I append null. That's gonna not throw an error. If you try to do this inside your little MySQL prompt and you didn't include the null, it'll say, hey, union has to have equal number of columns, just FYI, and it would get mad at you. Some SQL injection tools. I'm not gonna go over syntaxes or any like that because, like, just write your own, dude. Like, that's one of the coolest ways to learn, in my opinion, is try writing it yourself. Even if you think it's bad or even if you think it's inefficient, just try it out. Even if it only pulls out one record from a database or something like that. But these tools will help you fuzz for data and CTFs and whatnot like that. If you need them on CTFs, that's cool. They each support a certain variety of languages. I think SQL Map has the largest variety I've seen. These other ones, I've only had experience with Burp and OWASP Zap Scanner. I haven't even used SQL Ninja, but each will support their own languages.
Did we lose him again?
Angel, come back.
Angel.
I think we gotta hit him through the questions. Because I don't think he can hear us.
Yeah, hit him in the questions.
There we go.
I don't know what's going on with my audio, guys. Sorry about that. All right. Can anybody hear me now? I think we're good. Discord showing good.
Yes.
Okay, sweet. Talking about XML external entities and the injection of them. Funny fact, this is actually kind of just a feature of XML. XML is used to reference things, and it's kind of our fault for not sanitizing user inputs before it goes into the parser. So these XML objects, if you're not familiar with XML, it's a type of markup language to organize stuff in essence. Web servers might use XML to display content so that they can reference backend stuff and display the content to you. The exploitation of XXE or injection can lead to file disclosure. It can lead to denials of service, and you can also perform server-side request forgery. I've rarely seen examples of code execution. I think one really obscure code execution example that was on a CTF, and it just didn't seem very lifelike, I guess. Portswigger has a good lab on them that I have linked here. Yep. So talking about a little bit more on XXE, it can be found parsing pretty much anything. A lot of things will be formatted as XML just because it's a good way to format all that data, no matter the source. Out of bound XXE, or out of band, I should say. I can't read whatever. Usually means that your response, again, is coming from a different party, a different entity. It's not the same channel that you're communicating on. Corbin Leo has dealt with XXE injects in the past a good amount. He's got this website. It's a cool tool. I haven't used it. Shane was like, hey, this is a cool tool. I was like, yeah, that seems cool, but didn't get a chance to use it. Portswigger has a cool XXE file retrieval lab. That's what this screenshot is here. Just basically referencing the exploit where we have /etc password referenced, and the product ID is what's normally shown to the user. And I'm like, oh, cool. Let me reference that thing that I just told you to get, and it'll give me that. So that will disclose the /etc password file on a Linux file system. Here's a couple of write-ups and bug bounty for XXE via interactive voice response and CTF write-up. Cool real-world examples. CTF kind of real-world. Yeah. Talking about Shellshock, this is going to be a little quicker just because it's like a one-off vulnerability and it's CVE. And it's not as impactful in my opinion off the bat just because it can be patched. You just update bash, right? It's a vulnerability dealing with the improper sanitation, common theme tonight, of the user input. Basically, you can utilize the environmental variables of a server that's listening to execute commands. So I've got some examples here. So for instance, a local terminal, and this might be on web or something like that that you might encounter. On a local terminal, we have this variable, bread, set to this sign, who am I? And this stores the results of who am I. It doesn't store the literal string of who am I. It stores this, the output of it. It runs this and then gives you the output. So if I echo that back, it gives me Brawler, which is my username for that virtual machine. Depending on your backend configuration, you can be able to exploit this easily on that target backend. Oop, I think it was a copy of the slide. Basically, doing some hackery, we can get the commands executed on the server, and that usually looks like this. This is the most common example I've found, where you just swap out the user agent with this little escape type, and then you append all your commands to here. It's pretty cool, but again, just update bash if you don't want to get hit by it, I guess, until somebody finds something else again. Here are some labs for it. This is a virtual machine you download. This is a Try Hack Me machine that you interact with. It's a pretty good one. I will say it is less guided, but exploitation of this is fairly easy and well documented. The Docker Shellshock lab that I was trying out a while back, at the time of writing, it wasn't available. For some reason, the image wouldn't run properly on my end, but that could also just be my end. Links there. Talk about command injection in OpenVPN files. This is just a little like one-off cool thing that I thought was funny. Basically, if you look at the help for OpenVPN, we look at these two things down here. Run command after successful ton device open, which is basically like after you're connected and your VPN is going, cool, we'll run a command. Which you wonder, like, why? Why is that a feature? Why do we need that as a feature? It's cool, that's why. It actually has legitimate use cases. It can be equivalent to like the netcat-e that some systems have, where you run a command right after the connection. So here is kind of my configuration. This is my Try Hack Me file, and I've just added this here. I've added script security too, which dictates that, hey, this OpenVPN file has certain privileges that other defaults would not. And here's my command, actually. It's just going to echo this to the terminal wherever I run it, and I'll actually show an example of that right now. Believe this is it. Oh wait, actually, I actually did it to my full VPN. Just do a new connection. Okay, so we get the whole connection thing, and we look down debug, and oh, that's interesting. It sees this command, and it says it's open. Oh, we get this nice privs kiddo root, which I just thought that was pretty interesting. So just be careful, double check your OpenVPN files, and yeah, don't download random ones on the internet like I did this one time at Bandcamp. And there's just an example of what we saw. So talking about server-side template injection, I think this is one of our last couple of topics for next week's presentation. But server-side template injection, basically serving dynamic contact, has come down to us making templates that will load content into. Well, these templates have to be processed and stuff has to be kind of concatenated to it. In doing so, certain frameworks will mess up and process variables. I shouldn't say mess up because maybe that's what they were built to do and process the actual variables, but lack of user annotation will allow room for remote code execution or cross-site scripting and whatnot. Here's a cool CTF write-up on SSTI. You guys can check that out. But basically, here's an example. I think this is like a Jinja example for Flask. Jinja 2 is the framework for it. It would actually evaluate stuff within curly braces, which, looking back to the eval statement in our Python script, can be dangerous. Just checking audio really quick, make sure this is active. Cool. All right, so here's a little blog about Flask Jinja 2 exploitation. There's also a Flask room where you will do that type of activity, and they walk you through it pretty well. It's pretty noob friendly in my opinion. As a noob talking about how it takes the setup and whatnot, they walk you through it. There's an example right up, Gunship from the Hack the Box CTF. is a cool little activity that we did. Basically, it's a AST injection. It's a different framework, but we were able to get the web server to execute the commands for us. And here was the proof of concept that I wrote. And this was just pulled off of this blog that I found on AST injection. So the next couple of slides are over the Jinja, I spelled it wrong, Jinja 2 template rendering engine. And basically we're going to see how those curly braces will run code. So here I've got some functions in my server Flask app. Basically we have a function that says, hey, you can't run me, I'm server-side code, which is cool. That's our goal, right? We can notice that this is a globally defined Jinja environment variable, which allows us to run that. And that's kind of the way that we won't get full remote code execution, but we'll get some type of code execution. Basically, our template is here. We format this user input directly into it. And then when Jinja 2 renders that template, it actually processes that. So this string right here, I guess, if you were to narrow this down, this line of code would be kind of our issue and why we're able to exploit this. So the template engine will see your cool HTML and user input, and it'll see curly braces, and it'll be like, hey, that's a message from my framework to insert something into there. I should go ahead and do that. So for instance, I've got this vulnerable web app that I put together. This is pretty much just like a rundown of the Try Hack Me lab. Really quick though. And we have name, Breadman, cool, response, Breadman, whatever. If I put curly braces, just to mess around, and maybe I know a little bit about what's running on the back end because the user told me it's Flask or something, then I can mess with it a little bit. Oh, that's crazy. We added something together and it put it out as one string. Well, that can be a little bit frightening now, can it? So what we can actually do is, since there's a Jinja 2 defined global environmental variable, we can run it as a function, or it is a function. It's defined as a variable, and we can just run it. And it returns our server-side code that is in the script that we were not supposed to get to, that was not in the flow of the Flask app at all, which is kind of cool. Butter function, it's accursed. And that brings us to the end. Next time we'll be talking about process injection and hopefully getting into our next series. Thank you all for coming out tonight. Really do appreciate it. And yeah, everybody stay safe.